All right, let's dive in. Today we're taking a deep dive into the life of Antoine Lavoisier, the father of modern chemistry.
A fitting title, wouldn't you say?
Absolutely. And we've got a mountain of sources to pull from biographies, his scientific papers, historical accounts, you name it.
Sounds like we've got our work cut out for
Oh,
us.
yeah, but that's what makes these deep dives so fascinating. So, what I really want to figure out is how this guy went from being this wealthy Parisian to completely revolutionizing science, only to end up, well,
A victim of an actual revolution.
exactly. It's a story full of twists and turns, that's for sure.
But before we get to the dramatic ending, we should probably start at the beginning. Lay the groundwork.
Okay, so rewind to 1743. Lavoisier is born in Paris, and not just any part of Paris, we're talking prime real estate. His family well off, to say the least.
The best schools, connections, you name it. They spared no expense when it came to young Antoine's education.
Top notch in science and mathematics. But here's where it gets interesting. He actually studied law.
It's true. Can you imagine the father of modern chemistry almost becoming a lawyer? Talk about a different path.
Right. History might have taken a very different turn.
Luckily for science, though, his true passion couldn't be ignored.
Yeah. Talk about dodging a bullet. But that's not the only twist. This is where another key figure enters the scene. Marie-Anne Curet-Pauls, his wife.
Ah, Marianne. A fascinating figure in her own right.
She wasn't just there to, host dinner parties. She was a vital part of his scientific journey.
A true collaborator. Her contributions were essential to Lavoisier's success. We'll definitely dive deeper into that later, but it's important to acknowledge her influence from the very start.
Absolutely. And to top it all off, Lavoisier inherits a fortune.
Talk about luck.
I know, right?
Mhm.
This financial freedom allowed him to pursue his scientific interests without having to worry about, well, paying the bills.
It was a significant advantage at the time. Imagine having the resources to build your own laboratory, conduct any experiment you could dream up.
No grants to chase, no one telling him what research to prioritize. He was free to follow his curiosity wherever it led.
And it led him to some remarkable discoveries.
So, with his brilliant mind, a supportive partner, and a seemingly endless supply of funds, Lavoisier's scientific career takes off. At the young age of 25, he's appointed to the prestigious French Academy of Sciences.
It was a clear sign that his peers recognized his brilliance.
Like being drafted to the scientific all-star team.
Exactly. But even geniuses have to pay the bills, right?
True enough. To fund his research, Lavoisier also worked as a tax collector.
It sounds a bit mundane, doesn't it?
A side hustle for a scientific superstar. But, as we'll see, this seemingly insignificant detail ends up playing a huge role in his life later on.
It's true. That choice would have unforeseen and tragic consequences down the line.
But in these early years, Lavoisier's focus is on using science to make a real-world impact. He's all about solving practical problems,
You want to see how scientific knowledge could improve everyday life,
like figuring out how to improve street lighting in Paris.
making the city brighter and safer.
Right. But this guy's not just a one-trick pony. He publishes his first scientific paper at the age of 21.
21. A scientific prodigy.
And he's out there doing geological surveys. I mean, the man was nonstop.
A true polymath, driven to explore and understand the natural world in all its complexity.
But it's his later work that truly sets the world of chemistry on fire, so to speak. He gets really obsessed with combustion, burning stuff.
A fundamental process,
Yeah.
yet so poorly understood at the time.
It seems so basic now, but back then it was a total mystery.
The prevailing theory at the time was the phlogiston theory.
Phlogiston. Okay, tell me more about this.
The idea was that things contained this mysterious substance called phlogiston that was released when they burned.
It sounds a little far-fetched now, doesn't it?
What was the dominant theory for a long time? People thought it explained why things burned, why flames went up, all that.
But Lavoisier wasn't convinced, was he?
No, he wasn't. He had this incredibly meticulous way of conducting experiments, always focused on precise measurement and careful observation.
So he wasn't just theorizing, he was putting it to the test.
Exactly. And his results, well, they just didn't line up with the whole phlogiston idea.
The data told a different story, so what did he do? He threw out the old theory and came up with a new one.
In a way, yes. But it wasn't just about coming up with a new theory. It was about following the evidence wherever it led. And in this case, it led him to
Oxygen.
bingo.
Huh.
He figures out that oxygen plays a key role in combustion, a groundbreaking discovery that completely overturned the phlogiston theory.
This wasn't just a minor tweak, it was a complete paradigm shift in how people understood the world.
Precisely. And that's what makes Lavoisier so fascinating. He wasn't afraid to challenge the status quo, to trust his own observations, even when they contradicted established theories.
He was a true scientific revolutionary.
Exactly. And his work on oxygen and combustion had ripple effects that extended far beyond just explaining why things burn.
It changed the way we think about matter, reactions, everything.
Precisely. But that's not all. Lavoisier was just getting started. This is where he makes another major contribution: the law of conservation of mass.
Okay, break that down for me. What does that even mean?
Essentially, he proved that matter is neither created nor destroyed during chemical reactions. It might sound obvious now, but this was a radical concept back then.
So he's saying that stuff doesn't just disappear into thin air.
Exactly. Even though a substance might change, transform into something new, the total mass remains the same.
Wow, okay. I can see why that would blow people's minds back in the day.
It completely challenged the way people thought about matter and change.
And it had major implications, right?
Huge implications.
Yeah.
We're talking about one of the fundamental principles of chemistry, a principle that has influenced everything from our understanding of the universe to the development of modern technology.
It's incredible to think that he figured this out using, what, just some scales and meticulous observation?
It's a testament to his genius, his ability to see the underlying patterns and principles at play in the natural world.
So we've got a scientific superstar on our hands, but I have a feeling there's more to this story than just groundbreaking discoveries in the lab.
You're right. Lavoisier's life wasn't just about beakers and Bunsen burners. His personal life, his social connections, these things played a crucial role in shaping his destiny. And that's what we'll explore next. It's easy to get lost in the groundbreaking discoveries, but Lavoisier's life was more than just, flasks and formulas.
Right. We got to remember he was a person living in a specific time and place.
Exactly. And those external factors played a huge role in shaping his journey, both the good and the bad.
Okay, so let's talk about the good stuff first. We touched on Marie-Anne, his wife, earlier.
Ah, Marie-Anne, a remarkable woman.
She was way more than just a supportive spouse. She was brilliant in her own right.
Absolutely. It's fascinating how involved she was in his work. I mean, for starters, she was fluent in English and Latin.
No way. So she was like his personal translator, keeping him up to date on all the latest scientific papers from across Europe.
Exactly. She could read and understand research that Lavoisier couldn't access on his own. That's huge.
It's like having a direct line to the international scientific community. I bet that gave him a serious edge.
It definitely did.
Hmm.
But it doesn't stop there. Marie-Anne also illustrated his books and papers.
Hold on, she was an artist too.
Oh, yeah. Think about it. Detailed diagrams of his experiments, his equipment, all done by Marie-Anne.
That's incredible. It was a true partnership, wasn't it?
Absolutely. They were a team in every sense of the word. They bounced ideas off each other. She helped him refine his theories. It's amazing to think how much she contributed.
A true power couple of science. It really makes you wonder how different things might have been if women back then were given the same opportunities as men in science.
No doubt about it. We can only imagine how much knowledge was lost because women were excluded from these fields.
Okay, so we've talked about the good, a brilliant wife, wealth, recognition. But you mentioned there was a bad side to these advantages too, right?
Unfortunately, yes. Lavoisier's wealth and status, the very things that helped propel his career, also played a part in his downfall.
This is where his side gig as a tax collector comes back to bite him, isn't it? Enter the French Revolution, a period of intense social and political upheaval.
Exactly. You can't underestimate the impact of the revolution. The monarchy is overthrown. Anyone associated with the old regime is suddenly a target.
And tax collectors, well, they weren't exactly popular to begin with.
Let's just say they weren't winning any popularity contests. They were seen as symbols of oppression, of the inequality that fueled the revolution.
And Lavoisier, despite being this scientific genius, he gets caught in the crosshairs.
He was part of the Ferme Générale, a private tax collection agency that was widely seen as corrupt.
So even though she's doing groundbreaking science, his association with this agency painted a target on his back.
It did. And unfortunately, that association proved to be fatal. Despite his colleagues vouching for him, highlighting his scientific contributions, it wasn't enough to save him.
So he's arrested.
In 1793, yes. Despite pleas of innocence, testimonials about his work, his membership in the Ferme Générale sealed his fate. He was tried for treason and executed by guillotine on May 8, 1794.
Wow, what a tragic end. At the height of his career, gone, just like that. It's a stark reminder that brilliance doesn't always protect you from the political realities of the time.
It's a sobering thought, isn't it? But even though his life was cut short, Lavoisier's impact on science continues to this day.
That's the thing about ideas, isn't it? Once they're out there, they can't be taken back. So even though Lavoisier was gone, his work lived on.
Exactly. And his legacy goes way beyond his individual discoveries. He changed the entire way we think about science. But to really understand that, we need to take a closer look at what made his work so revolutionary.
Okay, so we've covered Lavoisier's fascinating life, his ups and downs, but let's get back to the heart of it all. What exactly makes him the father of modern chemistry?
It's more than just the discoveries themselves. It's how he transformed the entire field. Before Lavoisier, chemistry was, well, kind of messy.
Messy
There
how?
was a lot of qualitative observation, like this smells like sulfur, or this liquid turns red when you mix it with that.
Oh,
But Lavoisier brought in this rigor, this emphasis on measurement and quantitative
he
analysis.
was all about the data.
Exactly. He was like, okay, let's not just describe things. Let's measure them. Let's get precise.
So he's applying the principles of mathematics to chemistry.
Precisely. And that was revolutionary. It shifted chemistry from being this kind of, descriptive, almost philosophical science to a much more precise and analytical one.
So less alchemy, more like the chemistry we know and love today.
Exactly. And the impact of that shift is still felt today. Think about it. We already talked about the law of conservation of mass.
Right, which is like chemistry 101.
Yeah,
It's foundational.
exactly. And that came directly from Lavoisier's insistence on meticulous measurement. But there's more. Remember that systematic naming system he created for the elements, the one we still use today.
Yeah, the periodic table would be a chaotic mess without him.
Right, before his system, it was like, okay, we've got dephlogisticated air and inflammable air, and it was confusing.
No wonder they couldn't figure things out. It's like
Oh.
trying to build a house with no blueprints.
Exactly. Lavoisier's system brought order to the chaos. It allowed chemists to communicate clearly, to collaborate effectively.
It's like he gave them a common language.
Exactly. And that's what's so remarkable about his legacy. His work, done centuries ago, is still the foundation of how we understand the world around us. It's mind-blowing, really.
It is. So as we wrap up this deep dive into the life and legacy of Antoine Lavoisier, I'm left with this one thought. What if he hadn't been executed? What if he had had more time?
It's a question that haunts me, too. What other mysteries could he have solved? What other breakthroughs could he have made?
Yeah.
We'll never know for sure.
It's a tragic reminder that even the brightest minds can be victims of circumstance. But one thing is certain. Lavoisier's title as the father of modern chemistry is well-deserved.
Absolutely. He revolutionized the field. He gave us the tools, the language, the framework to understand the building blocks of our world.
And his story is both an inspiration and a cautionary tale. An inspiration to pursue knowledge with passion and rigor, and a cautionary tale about the importance of protecting scientific progress from the forces that seek to stifle it.
Well said. It's been a pleasure exploring Lavoisier's life and work with you.
Likewise. And to our listeners, we hope you enjoyed this deep dive into the world of Antoine Lavoisier. If you're interested in learning more, we encourage you to explore his writings and the history of chemistry. There's a whole universe of knowledge out there waiting to be discovered.
Until next time, keep those minds curious.